In this video, we take a look at conic sections and specifically the conic sections of ellipses. So remember that there's a bunch of different conic sections. We have circles, ellipses, parabolas, and hyperbolas that we are going to cover. Now what we're going to do is cover the ellipses. Now, the first thing I want to do is do the algebraic equation or the algebraic equations for an ellipse. If we center an ellipse at the origin, then we can write that equation of the ellipse as either x squared over a squared plus y squared over b squared equals 1, or as x squared over b squared plus y squared over a squared is equal to 1. The only difference between these two equations is which variable has the bigger number beneath it. So we'll call the a the bigger number. If that bigger number is underneath the x squared part, then the ellipse is going to be stretched out more in the x direction than it is in the y direction. On the other hand, if the a squared is underneath the y squared part, then the ellipse is going to be stretched out more in the y direction as opposed to the x direction. So whichever variable has the bigger number below it is going to determine the stretch of the ellipse, whether it's stretched more left and right or stretched more up and down. Now, once we've seen this, then we can state some of the information on an ellipse. The major axis of the ellipse is length 2a. The vertices on the ellipse are at the end of the major axis. So if it's more stretched out in the x direction, then the major axis is going to be along the x direction. And the vertices are going to be on the ellipse at the end of that major axis. The minor axis is length 2b, and we say covertices on the ellipse are at the end of the minor axis. So we have vertices and covertices of the ellipse. They are at the ends of the major axis and the minor axis. Two other points which are really important with an ellipse are the foci. Each ellipse is going to have two foci. That's the plural for focus. They are going to be located on the major axis, and each of them is going to be c units from the center. Now, this c is calculated by taking c squared is equal to a squared minus b squared on an ellipse. We'll have a different c for other conic sections, but for an ellipse, we get c squared is equal to a squared minus b squared. And the eccentricity is a number that tells you how stretched out the ellipse is from a standard circle. It's going to be c over a. We'll talk more about that later. So this is the basic information for an ellipse. Now, that information is essentially algebraic information. We can also define an ellipse geometrically. Geometrically, an ellipse is the set of all points where the distance from the point to the first focus added to the distance from the point to the second focus is constant. Let's take a look at that on a graph. So I have an ellipse drawn here, and it's stretched out more in the y direction. So the major axis is the y-axis. And the minor axis is the x-axis. It's stretched out less in the x direction. So we have the ellipse has equations x squared over 16 plus y squared over 25 is equal to 1. If I calculate the c, that's 3. And so you can see the two foci are along the major axis, and they're 3 units from the center. In this case, the center is the origin. Now I've put a point on this ellipse, and I've done it in such a way that I can move this point around the ellipse. If you take the distance from this point to the first focus, it's actually about 6.26. If you take the distance from that point to the other focus, it's about 3.74. And obviously, as we move the point around, those two individual distances are going to change. However, if I sum the two distances up, those two distances add to 10. So as I move this around, while the individual distances change a lot, so these change, summing them up adds to 10 no matter what point we are at along this ellipse. So each point has the sum of those two distances equaling 10. That is one way to describe an ellipse geometrically. Now, most of the problems that we're going to do in this class are algebraic based. So they are going to deal with the information on this page along with these two equations. But there's a lot of really nice features of ellipses that come from the geometrical creation of those ellipses. It turns out those foci are really nice points to be at if you're in a room and there's a lot of noise bouncing off of walls, things like that. So there's a lot of really nice applications of ellipses because of their unique geometry. And even orbits of planets are like that as well. Their orbit of planet, like the Earth around the sun, is basically elliptical, where the sun is one foci, or it's one focus, I should say. So let's go ahead and do some problems that we may see in our class. First, let's find the vertices, covertices, foci, length of the major axis, length of the minor axis, the eccentricity, and the distance between the foci for the given ellipse. Here we have the ellipse of x squared over 100 plus y squared over 64 is equal to 1. Now I want to point out this is a standard equation for the ellipse, and it's centered at the origin. So we're centered at the origin. That's not something that we were specifically asked to state, but that is something I want to state. And because there is a bigger number underneath the x squared, we know that this ellipse is going to be stretched out more in the x direction. Actually, let me undo that. Stretched out more in the x direction than it is going to be stretched out in the y direction. I'll make that really long there. Again, I'm just doing a very crude drawing over here. So the vertices are going to be at the end of the ellipse, at the ends which, in this case, which touch the x-axis. Now, the number in below the x squared is 100. So what that means is that a squared is equal to 100. So a has to be 10. Similarly, b squared is equal to 64. So that means b is equal to 8. Now I can decide where the vertices are. Since we start at the center, which is the origin, the vertices have to be a units to the right and to the left. So the vertices are at the points 10, comma 0 and -10, comma 0. The length of the major axis is 20. That's double what A is. Again, we're moving left and right, pretty straightforward to see. And then my co-vertices are going to be at the ends on the y-axis where the ellipse hits the y-axis. So my co-vertices are at 0, 8 and 0, -8. That means the length of the minor axis is double 8, which is 16. Guess I could have said 16 is 16. So I have the vertices, the co-vertices, the length of the major axis, the length of the minor axis. I don't have the foci yet, or the eccentricity, or the distance between the foci. All of those things are going to force me to find what that value of C is. And remember, for an ellipse, C squared is equal to A squared minus B squared. So in this case, C squared is equal to 100 minus 64. That's 36. So C squared is equal to 36, which means C has to be 6. Now I'm ready to figure out the foci. Real quick, they have to be on the major axis. So in this case, they're going to be on the x-axis. And that we know now that they are 6 units from the origin, left and right from the origin. So the two foci are the following. We have the point 6, 0, and the other point, which will be -6, 0. Again, we're moving left and right on the x-axis. The distance between the foci is just double 6. Just like the length of the major axis is double the A, the length of the minor axis is double the B. The distance between the foci is just going to be double the C. In that case, it's 12. In our case, it's 12. And then the only other thing it asks me for is the eccentricity. The eccentricity is C over A, which in this case is 6 over 10, which is 0.6. Notice that the eccentricity for this ellipse was a number between 0 and 1. In fact, if you think about it, since c squared is always a squared minus b squared, a is going to be the bigger number between a and c. They're both going to be positives, so it's going to be a bigger number in the denominator over a smaller number, or excuse me, a smaller number in the numerator divided by a bigger number. So it's always going to be between 0 and 1. For an ellipse, again, this is for an ellipse, that eccentricity is always between 0 and 1. So there you go. There are all of the different features of this ellipse. I like to draw a mini drawing just so that I can keep things in my head straight. Again, if you're moving left and right on the major axis versus up and down on the major axis. Let's take a look at another example. Here we start with the graph of an ellipse, and we're asked to find the equations and features of the ellipse. The equation and the features, we know what the equation looks like. The features we're going to find are the exact same features as what we found in the previous problem. So the vertices, co-vertices, foci, length of the major axis, length of the minor axis, distance between foci, and the eccentricity. Go ahead and push pause on the video and see if you can come up with those things along with the equation for this ellipse. All right, let's do this problem. Now, this is obviously an ellipse centered at the origin. Hopefully that's clear. And we can see it's stretched out more in the x direction than it is in the y direction. So I know that the equation is going to look like x squared over a squared. And then y plus y squared over b squared. So a is always the bigger number. I know it's stretched out more in the x direction. Now, what is a? Well, I can see that if I go from the origin, which is at my center, to the outermost point on this ellipse to the right, I've went 13 units to the right. Also 13 units to the left if I went that. So that means A is 13. Also, it's pretty clear that moving up and down, we move up and down 6 units. So therefore, B is equal to 6. So A is equal to 13, and then B is equal to 6. That means B squared is equal to 36, and A squared is going to be 169. So I can put that in my equation and have my actual equation done. X squared over 169 plus y squared over 36 is equal to 1. The vertices are going to be here at 13, 0 and negative 13, 0. The length of the major axis is just double 13, which is 26. The co-vertices are going to be here at 0, 6 and 0, negative 6. So 0, 6 and 0, negative 6. That's a length of the minor axis, which is 12. Double 6 is 12. And then I can figure out what the c squared is. Well, C squared is going to be A squared, 169, minus B squared, which is 36. If I take 169 and subtract 36, I get 133. That is not a perfect square. So we just say that C is the square root of 133. Now, what's that mean about the foci? Well, the foci are square root of 133 to the right and to the left of my origin. They're right and left because we're stretched out more right and left than I am up and down. So square root of 133, by the way, is about 11.53. So somewhere in here and somewhere in here are my two vertices. Excuse me, not vertices, my two foci. Excuse me. So there we go. Foci, square root of 133, comma 0, and the negative of the square root of 133, comma 0. The distance between the foci is twice the square root of 133. And if you were to do that, you just double that 11.53. You'd get about 23.07 if I don't round, 23.0607, depending on how the rounding is. And then the eccentricity is going to be the square root of 133 divided by 13. So that would be the eccentricity. Once again, if you calculate the square root of 133 and then divide it by 13, you get a number, just so that we get an approximation of about 0.8871. So there you go. Again, we get a number between 0 and 1. So from the graph, we saw how to find the equation of this ellipse and then how to find all of the features of this ellipse just by looking at the graph of said ellipse. Let's do another example like that. In this example, it says find the equation and the features of this ellipse. We're centered at the origin. We've went out 2 units in the x direction both ways, up and down 4 units in the y direction both ways. Go ahead and push pause on the video and try to find the equation for this and the features for this ellipse. All right. Well, in this case, we're stretched out more in the y direction. That's pretty clear visually speaking than we are in the x direction. So when we create our equation, the larger number, which we say is the a, is going to be placed in the denominator of the y squared. So it's going to be y squared over a squared, and then x squared is going to have b squared as its denominator. Now, in this case, the a, the longer value, is going to be the 4. We've stretched up and down 4 units, so the a is going to be 4. The b is going to be 2 because we stretched left and right 2 units. By the way, this means b squared is 4 and a squared is 16. I can put that into my equation. So my equation is x squared divided by 4 plus y squared divided by 16 is equal to 1. We know we're centered at the origin. We saw that. Now the vertices, because we've stretched out more in the y direction, the vertices are going to be at the points 0, 4 and 0, -4. Make sure we're going up and down there and not left and right. So 0, 4, 0, -4. On the graph, they're at the top and bottom of this ellipse. And then the length of the major axis is going to be 8 from vertex to vertex. The co-vertices are going to be moving left and right from the center. So our co-vertices are 2, 0, and -2, 0. Length of the minor axis is twice 2, which is 4. Double 2, you get 4. And then we can find the foci. Use the c squared equals a squared minus b squared formula for finding the c because this is an ellipse. C squared would be equal to 16 minus 4, which is a 12. So c is the square root of 12. Now, if you want to simplify that into 2 root 3 and rewrite root 12 as 2 root 3, you can. I think I'll just leave it as square root of 12 for right now. By the way, since the major axis is vertical, we have to move up and down the square root of 12 units to get to the foci. Therefore, the foci are at the point 0, square root of 12, and the other focus is at the point 0, negative square root of 12. Distance between the two foci is 2 times the square root of 12. Again, square root of 12 can be simplified, but not into a whole number. You'd have to rewrite it as 2 times root 3. Lastly, the eccentricity would be the square root of 12 divided by 4. And when I type that in on my calculator, so square root of 12 is the C, the A is the 4. I get about 0.8660. Just, I'll go out to 4 decimal places, even though we probably don't need to. But there you go. That's how to find all those features. Notice that 0.8660 was pretty close to the previous one I did. I got 0.88671. And if you look at the two graphs, they're stretched out similarly from a circle. The closer you are to a circle, the closer that eccentricity is going to be to 0. And the more and more stretched out you get, the closer that eccentricity is going to be to 1. But in this case, it came to about 0.8660. Again, some number between 0 and 1. All right, so we've done a couple of examples where I was given an equation and I found the features of an ellipse, and then I was given the graph and I found features of the ellipse. I've done the graph one twice. Now let's look at another type of problem. Let's find the distance between the foci of an ellipse if the major axis has length 22 and the minor axis has length 14. Now, notice something about this question. I don't even know which direction the major axis is in or the minor axis is in. But it really doesn't matter because if I have it wrong, if I have the major axis going up and down, then I could rotate 90 degrees, and then the major axis would be going left and right. The distance between the foci is going to be the same regardless of whether the ellipse is stretched out in the y direction or stretched out in the x direction. So we know that the major axis has length of 22. That means the value of A is going to be 11, because remember the major axis length is 2 times A. The minor axis has length of 14, so therefore we know B has to be 7. Now we want to find the distance between the foci, and that's going to cause us to have to find C. In an ellipse, C squared is equal to A squared minus B squared. So in this case, C squared is equal to 11 squared, which is 121, minus 7 squared, which is 49. That's 72. So C is equal to the square root of 72. Now that C is the distance between the foci and the center. If we're looking for the distance between the two foci, I double that. So it's 2 times the square root of 72. Again, 72 can be rewritten, if you'd like, as 6 times root 2. So that would be 2 times 6, which is 12, times the square root of 2. So if I wanted to rewrite 2 root 72 as 12 times square root of 2, I could. Or if somebody asks you for a decimal version that's been rounded, you could say, well, that's about 16.97. So there you go. That's the idea on that type of problem. Example 5 asks a different type of question. It says find the equation and the features of the ellipse if we know a couple of properties of that ellipse. Specifically, it says the center is at the origin. The major axis is along the y-axis having length 20, and the minor axis is length 12. Go ahead and push pause on this video if you want to try this on your own. In a couple of seconds, I will show you how it's done. All right, so the first thing I need to do is say, well, if the center is at the origin, my equation is going to look like x squared over a number plus y squared over a number is equal to 1. And we'll have to find those numbers based on A and B. But it says the major axis is along the y-axis having length 20. That means if I were to draw a sketch, it would be stretched out more in the y direction than it would be in the x direction. Obviously, this is a poor sketch. In fact, it's so poor that I'll redraw it. So stretched out more in the y direction than it is in the x direction. All right. So if the major axis has length 20, that means A has to be 10. And therefore A squared has to be 100, because 10 squared is equal to 100. B, since the minor axis has length 12, B is length 6, and B squared is 36. Now be careful, we've stretched out more along the y direction than along the x direction. And therefore, the 100 is going below the y squared, and the 36 is going below the x squared. The vertices are going to be at the top and bottom of the ellipse. So the vertices in this case are going to be 0, 10, and 0, -10. Length of the major axis, we already said that was 20, so we'll leave that alone. The co-vertices, well, we have to move left and right to hit the co-vertices. So the co-vertices will be at 6, 0, and at -6, 0. By the way, one interesting thing is vertices happen when this equation is true. If I plug in 10 for y, y squared gives me 100. 100 over 100 is equal to 1. And then the x squared becomes 0 squared. So the x term goes away when I plug in 0. And then I get 10 squared over 100 is equal to 1. Same thing with the co-vertices, but the y squared term goes away in that case. 6 squared over 36 is equal to 1. Length of minor axis, it already said it's 12, but I might as well write it down as well. Now, for c squared, in an ellipse, we have to calculate a squared minus b squared to get c squared. 100 minus 36 is 64. Square root of 64 is 8. So c is 8. Therefore, the foci are at 0, 8, and 0, -8. Notice that I had to go up and down to hit those. And the distance between the foci is 16. Eccentricity is c over a. Remember that a was 10, c was 8. So eccentricity is 8 over 10, which is 0.8. Once again, we have an ellipse, the eccentricity of which is between 0 and 1. So that's how we could find the equation of an ellipse and then find the features of that ellipse, given just a few features to begin with. Let's look at one more example like that. Here we're asked to find the equation and features of the ellipse if the center of the ellipse is at the origin, a vertex on the ellipse is at 9, 0, and a focus of the ellipse is at -6, 0. Go ahead and push pause on the video and try to find the features and the equation of this ellipse. All right, I'll show you how this is done now. So first off, center is at the origin, vertex is at 9, 0. That means this ellipse is stretched out more in the x direction than it is in the y direction. All right, so stretched out more in the x direction than it is in the y direction. And we also know that a focus is at -6, 0. So by the way, the other one would be at 6, 0. Same thing with the vertex. The vertex is at 9, 0. The other one would be at -9, 0 over here. That's because it's centered at the origin. If we were centered at a different point, it would be different. But because of the symmetry of an ellipse, that's what we end up with. So we're stretched out more in the x direction, and we know a vertex is at 9, 0. So we know that the value of a is going to be 9, and therefore a squared is going to be 81. I also know that's going to be underneath the x squared part because it's stretched out more in the x direction. So there's my vertices. Like I said, 9, 0 and -9, 0. Length of the major axis is 18. Now I don't know the value for B yet, but I will be able to figure that out because I know that I have a focus at -6, 0. In fact, I know both foci because of symmetry. One of them is going to be at 6, 0, and the other one is the given one at -6, 0. Again, that's because of the symmetry of the ellipse. Distance between the foci is 12. So I know that C has to be 6. If I know the C value and the A value, then I can use this equation for finding the, I used to be finding the C with that, and I can use that equation to find the value for B. In this case, because we're dealing with an ellipse, the way to find C is to do C squared is equal to A squared minus B squared. So in my case, 36 is equal to 81 minus B squared. 81 minus 36 is 45. And then if I add B squared to both sides, I get B squared is equal to 45. This is if I subtract 36 and add B squared. So B is equal to the square root of 45. I'll write that up here. By the way, that's 3 root 5 if you wanted to say that. And then B squared is equal to 45. So in the equation, since y squared has to be over b squared, I'll have y squared over 45. The covertices are going to be 0 comma square root of 45 and 0 comma negative square root of 45. So those are my two co-vertices. Length of the major axis is 2 times the square root of 45. Again, if you wanted to rewrite that, square root of 45 is 3 root 5. So you could get 6 times the square root of 5 if you wanted to rewrite that. And if you wanted a decimal, you could get an approximate decimal version 2. That's about 13.42 roughly. But there you go. So usually we use this equation of c squared equals a squared minus b squared to find the value for c in an ellipse. But you can also, if I know c and I know a, I can find the value for b. And if I knew the b and I knew the c, I could use this to find the value for a. And I think I've mentioned this, but just so that I mention it again, when we use the A, the B, and the C, we always have the convention that A, B, and C are positive. So that's why I took 9, rather than -9 as my A. That's why I took the positive square root of 45 rather than the negative square root of 45 as my B. And why I said that C was +6 rather than -6. So there you go. That's how you can utilize a few features of the ellipse to give you the equation for that ellipse, and then also all of the other features that we're concerned about in an ellipse. Now, I didn't write this last thing of eccentricity, so I might as well go ahead and do that. It's C over A, which in this case is 6/9. 6/9 is 2/3, so that's about 0.6667 if I round it to 4 decimal places, or 0.67 if I round it to 2 decimal places. So there we go. So now we've seen examples where we had to start with the features of an ellipse and come up with equations and other features. We started with the graph of ellipses and we came up with the equations and other features. And then I started with the equation of ellipse and I came up with the other features of the ellipse. So this is the end of our discussion on ellipses centered at the origin. We'll move these around and translate those and shift those so that they're not centered at the origin in another video.